This is Steve Ember.
And this is Sarah Long with the VOA Special English program, Explorations. Today we tell about a scientist who changed the way we understand the universe, Albert Einstein.
In the year 1905, Albert Einstein published some important papers in a German scientific magazine. They included one of the most important scientific documents in history. It was filled with mathematics. It explained what came to be called his special theory of relativity. 10 years later, he expanded it to a general theory of relativity. Albert Einstein's theories of relativity are about the basic ideas we use to describe natural happenings. They are about time, space, mass, movement, and gravity.
Albert Einstein was born in Ulm, Germany in 1879. His father owned a factory that made electrical devices. His mother enjoyed music and books. His parents were Jewish, but they did not observe many of the religion's rules. Albert was a quiet child who spent much of his time alone. He was slow to talk and had difficulty learning to read. When Albert was 5 years old, his father gave him a compass. The child was filled with wonder when he discovered that the compass needle always pointed in the same direction, to the north. He asked his father and his uncle what caused the needle to move. Their answers about magnetism and gravity were difficult for the boy to understand. Yet he spent a lot of time thinking about them. He said later that he felt something hidden had to be behind things.
Albert did not like school. The German schools of that time were not pleasant. Students could not ask questions. Albert said he felt as if he were in prison. One story says Albert told his Uncle Jacob how much he hated school, especially mathematics. His uncle told him to solve mathematical problems by pretending to be a policeman. "You are looking for someone," he said, "but you do not know who. Call him X. Find him by using the mathematical tools of algebra and geometry."
Albert learned to love mathematics. He was studying the complex mathematics of calculus when all his friends were still studying simple mathematics. Instead of playing with friends, he thought about things such as, what would happen if people could travel at the speed of light? Albert decided that he wanted to teach mathematics and physics. He attended the Federal Polytechnic Institute in Zurich, Switzerland. He graduated with honors, but could not get a teaching job. So he began working for the Swiss government as an inspector of patents for new inventions. The job was not demanding. He had a lot of time to think about some of his scientific theories.
From the time he was a boy, Albert Einstein had performed what he called thought experiments to test his ideas. He used his mind as a laboratory. By 1905, he had formed his ideas into theories that he published. In one paper, he said that light travels both in waves and in particles called photons. This idea is an important part of what is called the quantum theory. Another paper was about the motion of small particles suspended in a liquid or gas. It confirmed the atomic theory of matter. The most important of Albert Einstein's theories published that year became known as his special theory of relativity. He said the speed of light is always the same, almost 300,000 kilometers a second. Where the light is coming from, or who is measuring it, does not change the speed. However, he said, time can change, and mass can change, and length can change. They depend on where a person is in relation to an object or an event.
Imagine two space vehicles with a scientist traveling in each one. One spaceship is red, one is blue. Except for color, both spaceships are exactly alike. They pass one another far out in space. Neither scientist feels that his ship is moving. To each, it seems that the other ship is moving, not his. As they pass at high speed, the scientist in each ship measures how long it takes a beam of light to travel from the floor to the top of his spaceship, hit a mirror, and return to the floor. Each spaceship has a window that lets each scientist see the experiment of the other.
They begin their experiments at exactly the same moment. The scientist in the blue ship sees his beam of light go straight up and come straight down. But he sees that the light beam in the red ship does not do this. The red ship is moving so fast that the beam does not appear to go straight up. It forms a path up and down that looks like an upside-down V. The scientist in the red ship would see exactly the same thing as he watched the experiment by the other scientist. He could say that time passed more slowly in the other ship. Each scientist would be correct, because the passing of time is linked to the position of the observer. Each scientist also would see that the other spaceship was shorter than his own. The higher the speeds the spaceships were traveling, the shorter the other ship would appear. And although the other ship would seem shorter, its mass would increase. It would seem to get heavier. The ideas were difficult to accept. Yet other scientists did experiments to prove that Einstein's theory was correct.
10 years after his paper on the special theory of relativity, Albert Einstein finished work on another theory. It described what he called his general theory of relativity. It expanded his special theory to include the motion of objects that are gaining speed. This theory offered new ideas about gravity and the close relationship between matter and energy. It built on the ideas about mass he had expressed in 1905. Einstein said that an object loses mass when it gives off light, which is a kind of energy. He believed that matter and energy were different forms of the same thing. That was the basis of his famous mathematical statement, E equals mc squared, Energy equals mass times the speed of light squared. This statement or formula explained that a great amount of energy could come from a small piece of matter. It explained how the sun could give off heat and light for millions of years. This formula also led to the discovery of atomic energy.
In his general theory of relativity, Einstein said that gravity, like time, is not always the same. Gravity changes as observers speed up or slow down. He also said that gravity from very large objects, such as stars, could turn the path of light waves that passed nearby. This seemed unbelievable, but in 1919, British scientists confirmed his theory when the sun was completely blocked during a solar eclipse. Albert Einstein immediately became famous around the world. In 1921, he won the Nobel Prize in Physics. It was given to him not for his theories of relativity, but for his discovery of the law of the photoelectric effect. This scientific law explained how and why some metals give off electrons after light falls on their surfaces. The discovery led to the development of modern electronics, including radio and television.
Albert Einstein taught in Switzerland and Germany. He left Germany when Adolf Hitler came to power in 1933. He moved to the United States to continue his research. He worked at the Institute for Advanced Study in Princeton, New Jersey. Einstein became a citizen of the United States in 1940.
Einstein was a famous man, but you would not have known that by looking at him. His white hair was long and wild. He wore old clothes. He showed an inner joy when he was playing his violin or talking about his work. Students and friends said he had a way of explaining difficult ideas using images that were easy to understand. Albert Einstein opposed wars. Yet he wrote to President Franklin Roosevelt in 1939 to advise him that the United States should develop an atomic bomb before Germany did. Einstein spent the last 25 years of his life working on what he called a unified field theory. He hoped to find a common mathematical statement that could tie together all the different parts of physics. He did not succeed. Albert Einstein died in 1955. He was 76 years old.